a homework problem that you want to go over, and then we can help you walk through it.
I don't have any specific questions as of now.
Do you have a specific topic you want to go over? Like, what are you guys are learning right now?
Um, Give me 1 second on that. I'm looking through my notes to see what I need more help on.
Okay. Joseph, if you want, you can have like a window up, I guess. Like share your screen where you have something you can write on, at least. So,
Yeah. Okay. I don't have like a specific presentation because I wasn't told like whether I should make one or not. But I do have like a review sheet from the Society of Physics Students that has just things that um are apparently like going to be on the exam. I think.
oh, okay. You can share that if you want.
Okay. Oh, sure. Let me see. Um, okay. Yeah, and then I guess whenever like a specific question comes by, I guess we'll talk about it. I guess. Oh yeah, you can see it, right? The file.
Yeah, I can see it.
Okay. Yeah, it has like some units, solving linear equations, uh, average speed, and yeah, some vector stuff. It's okay.
So I guess since you have the review sheet up, if you want, you can go over vectors, I guess, because that's the first topic.
All right. So let me see then. Okay. Uh, so I'm trying to find where it starts. Let's see. It's run up here. All right. So let's see. Do you think I should just go over some specific problems? I guess.
Yeah,
Like
I think
okay.
going over like a specific problem, and if they have any questions about like a particular step, you can answer it.
Okay. That sounds good. Um. So I guess we'll start off with this one because this seems to be the first problem that sort of mentions vectors. Um, so it says vector v1 is 6.2 units long and points along the negative x-axis. So, you know what? I should actually probably draw this. I'm gonna open up, I guess, a page on OneNote, and then I could sort of share this as well. So let's see. Vector v1 is 6.2 units long. And it points in the negative x-axis. Here's x, y. So this is what the vector would look like. 6.2 units. Oops. And vector v2 is 8.3 units long, and it points 50 degrees to the positive x-axis. So that would look something like this. 50 degrees. And you know what? Instead of these, let me just label them vector 1 and vector 2. And the question asks, what are the x and y components of vector v1? So we want to calculate v1x and v1y. And you know what, I'm actually going to organize this a bit better. So v1, if you want to write it, I guess, as a vector, you could write it, I guess, like this. If you want v1x, v1y, since there's only 2 dimensions. And v1x, v1y. Can anyone tell me what you think v1x is based on the information? It says that v1 is 6.2 units long and v2 is 8.3 units long. So what do you guys, if anybody wants to unmute, like, what do you think v1x would be? Or, I don't know, maybe I'm starting off with like too simple of a problem. I don't know. What do you guys think right now? Well, okay. So I guess I'll explain this a little bit. So as you can see, v1, it points in the negative x direction. So, and it also says that it's 6.2 units long. So this whole vector is pointing in the x direction, essentially, and it's pointing in the negative x direction. So all of this vector is pointing in the x direction, all of this 6.2 units. So you can say that the x component of the v1 vector is 6.2 units. And the v1y, can anybody just quickly unmute and say what v1y would be if all of this is pointing in the x direction?
Would it be 0?
Yes, it would just be 0 units because all of this vector is pointing in the v1 direction. Now, I suppose it's also asking for v2. Yep. So it's now asking for the components of v2. So we can write v2 like this. There's obviously many different ways you could sort of write a vector. It doesn't really matter. Like, I don't know how they did in physics 102. Maybe they represent it like this. Y hat, where these are just the unit vectors. I don't even know if you guys learned unit vectors yet. It's just like the unit direction. Like this would be 1, 0, and then the y hat with that thing up here would be 0, 1. But either way, it doesn't matter. It's all like the same sort of notation in a way. So let's find the components. So here, the vector, it's obviously slightly more complicated. Not all of the vectors pointing in the x, not all of the vectors pointing in the y. There's like a mix of the two. However, we're given that the length of the vector, like this total length right here, is 8.3 units. Now, does anybody have any idea how we could find these components? Or does anybody like think they know how they would solve this, find the components? You can even like unmute if you have like no idea, because I just want to gauge like where everyone's at right now.
Well, I have a general idea of what you're supposed to do, but I'm not very good at the steps involving it, because I know that you're able to use the length of the vector as well as the angle given, but like the steps involving it, I'm still like trying to get.
I got you.
Yeah.
Okay. I'll explain this then. So basically, how you find the components of the vector, you find how much of this arrow is pointing in the x direction and how much of it is pointing in the y direction. And the way you sort of solve this is by just making it as a right triangle. So you see this is 50 degrees, this is 8.3 units, and basically This is the x component. The length of this arrow would be the x component, and the length of this arrow would be the y component. And one thing just that's commonly used is that if it's pointing to the right, it's positive. If it's pointing up, it's positive as well. And if it's pointing to the left, it's negative. Pointing down, it's negative. That's just the common convention. However, for some problems, they might explicitly say that down is positive, for example. But in this case, it's just assuming the simple, just convention that right is positive, up is positive. So with that sort of conventionality out of the way, I guess, in order to find the length of v2x and the length of v2y, which would be the components, you really just have to use just some simple trigonometry. I'm sure a lot of you know SOHCAHTOA, sine of theta equals opposite over hypotenuse, cosine. You know what? I'll even write these all. I'll probably put them down here just so you can have them all shown. Sine theta equals opposite length, so the side opposite to the angle, which would be this one, over the hypotenuse, which is this, and cosine theta equals adjacent over hypotenuse, and tan theta equals opposite over adjacent. And so the way you would figure out which trigonometric identity you want to use to find the component is by knowing what you want. So let's say we want to find v2x, that's what we want, and gauging the information that we already have. So you would see that v2x is in the adjacent direction. It's the actually, how should I explain this? The adjacent length is what we want, and we have the angle and the length, the hypotenuse of the triangle. So if we want the adjacent length and we have the hypotenuse and the angle, which trigonometric identity do you think we would use? Just unmute if you think you know which one we would use. If we have, the hypotenuse, the angle, and we want to find the adjacent.
We would need to use cosine.
Yeah, basically, yeah. So you just use cosine. And the way you would solve it is the adjacent is equal to, hypotenuse times cosine theta, just by the equation itself. So v2x is just the hypotenuse, which is 8.3 units, times cosine of theta, which in this case is 50 degrees. So times cosine of 50 degrees. And I'm going to assume that, guys, calculators on the exam, you wouldn't just leave it as cosine 50. So the mode, make sure your calculator's in degree if you're using like a TI-84 or something. So 8.3 times cosine 50, that's just going to be about 5.335 units. And that would be the x component. Now, can anyone tell me how they would get the y component?
Wouldn't you need to use wouldn't you need to use sine since you have the angle and the hypotenuse, but you need the opposite length?
Exactly. That's what you would use. Opposite is equal to hypotenuse times sine of theta. And this is how you would get it, just by moving the hypotenuse to the other side. And it's another simple thing. You just do 8.3 units times sine of 50 degrees. And for this, if you plug it into the calculator, you get about 6.358. All right, 6.358 units. Also, one thing I want to ask, on the exam, it's usually just like multiple choice, right? They're not going to be like too picky about whether you get like a significant figure or anything. It's not going to be like mastering physics, right? I just want to make sure. Can anybody just unmute to tell me if they're serious about significant figures or whatnot?
Nah, I'm not too serious about significant figures.
Okay, that's good then. So this is how you would find the components or the components of a two-dimensional vector. Now, let's see. Another problem you might also get asked, they probably have a couple practice problems here. Let me think for a second. If they wanted you to actually find the length of V2, for example, i.e. like the length of the hypotenuse, does anybody have any idea how they would find V2 if you were given, let's say you were just given the components. Let's flip the question around. Let's say you were given the components for Vx and Vy, but you want to find the length and the angle. Does anybody have any idea how they would do that? We'll start with the length just to make it a bit more consistent. How would you find the length of V2?
Wait, excuse me. When you say when you say components, what do you mean by components exactly?
By components, I mean you're given like a V2x and V2y. Like you're given the like how much of the vector is in the x direction and how much of the vector is in the y direction. You're given these two values basically. Like if you were given these two values, how would you find the length of V2? Which I guess you can sort of write as this in a way.
I forgot the name of it off the top of my head, but I know that a squared plus b squared equals c squared. I forgot its name.
Yes.
At the moment.
Exactly. It's a Pythagorean theorem. That's what you would use.
All right. Thank you.
No problem. So that's what you would use. In fact, let me see. So yeah, I'm sure you know that. Let's say this is A, this is B, and this is C. I'm sure you know that from Pythagorean theorem, c squared is equal to a squared plus b squared. If you don't know that, definitely try to remember this. You're going to be using probably a lot of trigonometry if you're dealing with vectors. So if you want to find the hypotenuse, i.e. c, you would just, take the square root of this sum. Just, square root that and then square root this, because that would cancel out the square. So in this case, our length, we can just denote as this. It's just a denotation of the length of the hypotenuse, and it would be v2x squared plus v2y squared. And in fact, if you square these two numbers, you can try it out on your own. I'll also do it. You will get, and also you got to square root it as well. I forgot that. Get square root. If you square these two numbers, you get 8 squared, square root that, that. You get about the answer. It might be a little bit off because of rounding and stuff, but you get essentially the same answer. 8.3 units for the length. Now, this one can be a bit tricky, and I'm actually going to go a bit into depth with this. I'm not sure how much depth they really go into this, but finding the angle sometimes of a vector can be tricky if the direction is sort of, if it's in the third quadrant, for example, or the fourth quadrant of this coordinate axes. But we'll start off with, I guess, I'll just explain the simple case of getting the angle for this. So, I kind of already just gave it away. But does anybody actually are you even asked to find the angle? Oh yeah, you can be. All right, yeah, you can be. What's it called? So if I wanted to find the angle of vector 2, does anybody remember how they would do that? Does anybody have any ideas? Like whether it be Pythagorean theorem, using one of these trigonometric identities down here. Does anybody have any ideas how you'd find the angle? If they want to mute real quick. All right, yeah, this one is a bit tricky to figure out. But what you would actually need to do is take the arctan of the opposite and adjacent. I should have mentioned that at first. It's the same situation as before. You're given the two components, right? That's what I said like at the beginning. Let's say you're given the two components. You want to find the length and the angle. So we found the length using the two components. If you want to find the angle, the best thing to do is use one of these trigonometric identities. And the one you would want to use is the one that has opposite over adjacent, because you have both the opposite. You have v2y and you have v2x. And this is probably a bad time to ask, but can you guys see my mouse? Because I've been kind of moving it a lot lately.
Yeah, I can see.
Okay, I just want to make sure. So yeah, so you would take the arctan, or the inverse tangent of opposite over adjacent, in order to get the angle. And it would be opposite, v2y over the adjacent. Now this can kind of be I guess I might have stumbled a bit while explaining this. Does everyone get where I got this from? Or is anybody confused how I got this formula for getting the angle? Is anybody confused?
If you can explain it again so that I can, just so I can just try to understand it again.
I see. All right, so let me try and go a little bit slower with this. So we know that tangent of theta is equal to opposite over adjacent. That's just one thing from trigonometry that we know. And we also know, obviously, all these other trigonometric identities. That's one thing you should definitely try to know. So what do we have? Like I said at the beginning, we're trying to find the length and the angle of this vector 2. And we have the two components. We have the x component right here, and we have the y component. Let's say there's a problem where you're given those components. So in order to find the angle, you could, like I said, well, not like I said, it's just true. There's many ways to solve these problems. How should I say this? Sorry, I'm just trying to catch my brain back. What's it called? So, yeah, you're given the x and the y components. That's just something you're given already. So what that means is you're given the opposite and the adjacent lengths. Do you understand that? Can you unmute just to say yes or no? Do you understand?
Yes.
Okay. So we have the opposite and the adjacent. Those are the two things we already have in the problem. So if we wanted to find the angle, and 50 is opposite over adjacent, you would just take the arctan, of both sides in order to cancel out the tan. Sort of the same thing as if you're doing like a square root on a square. You're just canceling them. And you do it on both sides, because that's how algebra works. And you get theta equals the arctan opposite over adjacent. And the opposite is v2y and the adjacent is v2x. So if you plug those numbers in, you would get theta. Now, if you find the length first, the length is the hypotenuse, right? It's 8.3. It's the hypotenuse of this right triangle. So if you do find the length first, you could, use sine, for example. You could do theta is equal to the inverse sine of the opposite over the hypotenuse, because you have v2y and you have the length. However, if you were just asked to find the angle, you would just want to work with the information you're given with. The quickest way to sort of solve this problem is to work with what you have. And like I said at the beginning of the problem, let's pretend you have v2x and v2y. So you would want to use the tangent trigonometric identity to find theta. And in fact, if you plug this in, v2y was, should move this up a little. b2y was 6.358 divided by, oops, 5.335. Should get about 50 degrees, or 49.999. But either way, yeah. If you see that on the test, then you should know it's just 50 degrees, because yeah, it might just be off by rounding and stuff. So I don't know if I kind of clarified it a little bit more. How do you feel about it now? Because honestly, I might have confused it a bit more. I hope not.
Well, me personally, I understand it better now that you've explained it, and I understand the steps more.
All right, that's good. All right, so that's good. All right, so far we know how to find the components, and we know how to find the lengths and the angle if we were given the components. So yeah, I guess we kind of dragged this problem out for a bit longer. So it's called. We should work on a new one. Let's see. This is probably a good one actually. Express your answers. Oh, they want the component of the sum. Okay. Before I move on to another question, would you guys want me to do to go over a question like this, where you're having three vectors and you want to find like the sum of the vector, the three vectors? How would you guys feel about me doing a problem like this, or am I dragging on vectors for too long? What do you guys want me to do? You guys want me to try one of these problems, or do you want me to move on maybe to another topic? What do you guys think?
I well, I think we should move on to another topic. But that's me personally. I'm not sure if anyone else wants to stay on vectors for a little while longer.
Yeah. Well, I guess oh, Julia?
I was gonna say, we can try moving on to another topic, and if another question about vectors come up, we can just go back.
Yeah, okay, that's fine. All right. So, all right, we'll move on from vectors for now. So, would you guys maybe want to talk about, I don't know, how to find average speed, or maybe want to talk about working with different units? Yeah, from this sheet, there's just a couple. Seems to be unit conversion problems. How to convert from maybe nanometers to meters, for example. Would you guys want to go over problems like that, I suppose, or maybe problems, I don't know, like solving linear equations, solving for x, dividing fractions? Is there anything you guys would prefer specifically that I listed?
I'm sorry. Say that again. I didn't hear you. I didn't quite hear you.
Oh, I'm sorry. So what topics would you guys want me to go over? Do you want me to do a couple problems on dividing or multiplying fractions, or just working with fractions in general? So that'd be one thing. Or do you want me to do some practice problems relating to how to convert between different units, such as from nanometers to meters, or how to work with things like kilometers per hour and how to get distance from that? I guess that would be a second thing. I'm kind of explaining it a bit too, probably. Let me. Would you like me to go over a practice problem that involves working with fractions? Would you like me to go over a problem that involves working with unit conversions? Or how about solving linear equations, like finding x? Is there anything you guys want specifically?
I I need a little bit more assistance when it comes to fractions because I still do tend to mess up when it comes to fractions.
Yeah, okay. So we'll do a couple of practice problems on that then. All right. So let me just see where this starts. Okay, multiplying, dividing fractions. Okay. So okay. All right. So let's see. Just trying to think of a good one to start off with. All right. Let me just. I guess I'll write something. So start off with something like this: 3 divided by 13/12 is the same thing as 3/8 times a over b. So one of the properties of dividing fractions is that it's the same thing as multiplying by its reciprocal. So does anybody have any idea what a over b would be for this?
Well, if you were speaking about the reciprocal, I know I'm pretty sure isn't the reciprocal 3/8, 8/3, or am I?
Yeah, that's the reciprocal for 3/8.
Oh wait, no, I forgot. You keep change for. So it'd be wait. Are you talking? So you're asking for the reciprocal of 13/12, correct?
Yes. Yeah.
Oh, yeah, 12/13. Apologies.
It's all right. That's exactly what it would be. 12/13. And yeah, like that's what you would. That's just like what you would do because it's just a lot harder to sort of divide by fractions if you think about it because it's just it kind of makes it hard to see where you divide things. Like for example, I'm just trying to think of an example. Like 3/8 over. Let me do this 9/12, for example. You could solve this by doing, I don't know, like you could divide the numerator by 3 and then divide this by 3 and you get 1 and then 3 here. Yeah, but overall, yeah, it's just not the good thing to do. You want to, that's just the thing, like if you're given a problem where you're dividing by fractions, you always want to, like you said, keep change flip. You want to multiply by the reciprocal of the denominator or the thing that would be at the bottom.
Okay.
Yeah. And I guess let's simplify this as well. I guess we'll simplify this to a single fraction. So now that we got that this is equal to 3/8 times 12/13, yeah, we can simplify this a little bit. So the way that I sort of like to do it is, I guess, let's do it like this. Let's make it into its prime factors. So 8 is the same thing as 2 times 2 times 2, and 12, let's say it's 4 times 3, so 2 times 3. And this is probably, I guess, if you are simplifying fractions, it's probably going to be the most, tedious part, because you got to try and think about how far you can break this down into integers multiplied by other integers. And that can be kind of tedious, because let's say, 70, you could be like, okay, that's 10 times 7, 7's a prime number, what about 10? That's 5 times 2 times 7. Oh, there we go. That's the complete one. So that's probably going to be the most tedious part, but it'll be fine once you get it. And 13 is also a prime number, obviously. So if we simplify this, we can cancel out a 2 from up here, and then another 2, and overall it just ends up being 3 halves times 3/13, which is 9 over, because you just multiply the numerators by the numerators and the denominators by the denominators, 9/26. And one thing that you might have a question about is why can you do this? Like, why is this all just magically work out? Um, well, when it's just multiplying and dividing things, you can all, I guess, sort of think about it like this. Like, if you wanted to have it just things being multiplied together, this may be going a bit too much into depth with it, but you can all think of it as just a string of numbers being multiplied whenever you're working with fractions. And did I forget something? Oh yeah, here we go. And the power to the -1 just means it's a fraction. So 2 is equal to 1. So this will just be 1, and then 1 times anything is just 1. So, or no, 1 times anything is just itself. So you don't even really have to consider it. So these really, you can think of them as just canceling out in a way. And overall, you end up with 3 times 3 times 2 -1 times 13 -1. And anything with a -1 is just 1 over itself. So it's just 3 times 3 is 1/2 times 1 over 13. And overall, okay, we can think of 3 as 3 over 1. So yeah, then you do the same thing as usual. Multiply the numerators, you get 9. Multiply the denominators, you get 26. But that was probably going a bit too much into depth with it, because I just wanted to, because working with all these different division symbols can kind of make it a bit confusing at times. And I kind of wanted to just show it all in one notation so it all makes sense, I guess. Like, why can you cancel these out? Even though it may seem obvious to some, it may not be obvious to everyone. So that's why I did it. But, what's it called? Does anybody have any questions, I guess, about dividing fractions? Or how are you feeling, William?
I feel better at being able to handle dividing fractions now that I see it and my brain is refreshed on it.
That's great. All right. So yeah. All right. So I guess that was dividing fractions. Multiplying fractions. I mean, if you wanted to multiply 3/8 times 12 over 13, it's the same thing. You just multiply numerators and the denominators, and you can simplify it at all. It's nothing really too different, so I won't go over an example with that. Just trying to see if there's any other specific questions that might have. Yeah, and I already said that if you have something like this, you can treat it as just the same thing as 3 over 1. So take the reciprocal of that. Keep change flip 1/3. Let's see. Similar problems. And then this eventually, once you multiply these two fractions, they'll become one fraction, one at the top and one at the bottom. And it just becomes another division problem. So I won't go into too much of this unless anybody brings it up if they want to see it.
Do you want to move on to linear problems or problems involving velocity, speed?
Yeah. What would you guys prefer? Do you guys want to see me solving linear equations, like trying to find x, or do you want to see maybe trying to find something like the average speed? Because that could actually be tricky, finding the average speed. Be a bit tricky at first to see it. What do you guys think?
I think velocity, like finding the average speed and dealing with velocity, is what will help me out a lot, because like I said, anything dealing with velocity I do have a little bit trouble on, because I can do the math, but it's just figuring out where what to plug in, where it goes, and then just yeah.
I completely agree. It can be a bit tricky at first to sort of see where everything goes. So we'll do one of those definitely. Let me see if I can find one. I think, is it something? Yeah, this is mainly just scientific notation. Oh, that's another thing we could go over later if you guys want. I mean, it's probably nothing too big though. Alright, let me see. You're deriving, well, okay. Velocity, alright, here we go. So, just trying to see if there's any good problem, because we could honestly do the one at the top. This is laps. Yeah, you know, let's actually go through these. Here's the distance. Okay, that's just a unit problem. Yeah, let's do this one. Alright. So one way that's kind of good that you could sort of get a better idea of what's going on in these type of problems is to sort of draw a graph. Or at least I think so for most of them. I'll have to see how the other problems are. But let me show you what I mean. So we'll start off with this problem. If you are driving 95 kilometers per hour along a straight road and you look to the side for 1.5 seconds, how far do you travel during that period? So the speed is constant. So just create a line here separating these. If you're driving, so all right. Let's draw a graph. So right now, just trying to think of the best way to sort of draw this. Yeah, you know, it might be a bit too complicated to draw it. I mean, it's just a straight line, but I'm not sure if it would really help in the test or anything. It might just be a waste of time. First side 1.5 seconds. Further travel. Whatever, I'll just go with the intuition then. Alright, I forget the graph. So basically, what this is saying is that for 1.5 seconds, you're traveling 95 kilometers per hour. And it's asking how far do you travel. So, if your speed is constant, if you're traveling, you know, in reality 95 kilometers per hour and that stays the same, all you really need to do to find the distance is multiply by the velocity and multiply it by time. And you can even see that with the units. The speed units is kilometers per hour. So that's, you can convert that into meters per second, which is what you would want to do, I guess, per se, because it's the SI unit. And then time you can convert into seconds, and you can see that these cancel out, and you'll just be left with meters, which is a unit of distance. So for something like that, that's all you would really have to do. Of course, the trickiest part, this is honestly more of a unit conversion problem now I think about it. So, you know, in order to convert from kilometers per hour, you would, let's see. Well, first thing, we'll do the distance. So kilometers, there are 1,000 meters in 1 kilometer, and you can cancel out the bottom and the top. So now we have meters at the top, and you can convert this to seconds by doing 1 hour over 60 minutes. So there's 60 minutes in 1 hour. Hours cancel, and you're left with minutes at the bottom. 1 minute over 60 seconds. Cancel out the minutes, top and bottom. And the only 2 units left are minutes and seconds. And, oh, no. This is the speed. My bad. V equals this. And, you know, multiplying fractions again. I guess I could see where that's coming in. So once again, multiply the numerators. 95 times 1,000 times 1 is just 1. And divided by 1 times 60 at the bottom. So that would be the denominator. And for this, you should get about 26.389, I guess, meters per second. And if you multiply that by time, so it's, oh, perfect, it's already in seconds. So do the v times t, so multiply this, 9 meters per second, times the amount of time that you're at that speed, 1.5 seconds, you get 39.58, which should be correct. It doesn't really, I don't think it gives the answer, but I believe that's what it should be. Now, okay, I'm pretty sure, I'm trying to find one where you have to find the average speed, because that one can be tricky at times. So, but before I try to find one of those, okay, never mind, there is one here. Okay, never mind. That's good. So we'll do this one next. Does anybody have any questions about how I did this problem up here? Problem 2.01. Or does everyone feel comfortable with how this one worked out? What do you guys think?
I feel comfortable with how it worked out.
Okay, that's good. And, oh yeah, got to put meters there. That's the unit. All right. So yeah, let's move on from that one. And let's try to do one where you have to find average speed, because that one could be a bit complicated. And there's one right here. So let's see. You're driving home from school steadily at this speed for a distance of 160 kilometers. So you travel at this speed for this distance. It then begins to rain, and you slow to 65 kilometers per hour instantly. So instantaneously, like, you don't slowly slow down. You don't go from 98 to 88 to 78. No, you go from 98 to 65. Now, while that may not seem, physically possible, okay, it's a lot theoretically. So this is still, like, I guess, a good problem to discuss. And it also, it introduces to some things in calculus, but you'll figure that out later if you do take calculus. I don't know how this works. But, what's it called? So, yeah, let's pretend that you instantly go from 98 to 65. And then once you're at that speed, you travel at that speed for you travel at that speed for some amount of time. It's not given, but overall, the overall time it took you to get home, like, for this whole process, was about 5 hours. So, how do we break this one down? So, it's asking for how far is your hometown from school. Let's do that one first. So, we know that you travel 160 kilometers for one part of the trip. We can break this trip into two different parts. Trip, one part you travel 160 kilometers, and we don't know the amount of time. We know the distance that you travel. We don't know the amount of time this lasted. And we know the speed you were going the whole time. So I guess we can call that B1 as well. We know you were going 98 kilometers per hour. And then the second part of the trip, whether it be longer or shorter, I'm not really sure yet. We know that your distance 2, we don't know the distance actually. That's what we need to find, because then the total distance will be the total distance it takes you to go home. We do know we don't know the time that it takes. We still don't know this. We know the total time. So I should also, I guess, write the sum. We don't know this. We do know this. This is about 5 hours. And you don't really need to add the speed, so I won't do that. But we do know V2 is 65 kilometers per hour. Now, on the test, I don't know if this is something you really want to do to kind of break it all down. Like, well, I'm trying to. obviously, like the first, like if you are doing problems like this, it is good to break it down as much as possible. Like especially if it's your first time doing it. But on the test, you should like practice this a lot and try to do a couple practice problems on this so that you really get the hang of it. So you don't have to break it down as much, or you don't have to like write it all out on the exam. You know, I don't know if I'm really giving good advice. Just let me just solve the problem. So what we're trying to find is D1 plus D2. And let me see. You're driving home from school steadily at 98 kilometers per hour for 160 kilometers. So let's see. You can find. You can find the distance that you're traveling here if you have the time, because remember what it's essentially using the same equation. D1 is equal to V1 times T1, and D2 is equal to V2 times T2. If only we knew the time that we were traveling at this speed, could we find the distance? Now, let's see. In order to get T1, one thing you may notice as you're working through this is we have the sum. We do not have the two times. However, if we do have one of the times, if we get T1, for instance, we could find T2. And if we find T2, we can put it in this formula, and we can get the D2. And that's what we need to complete the problem. We'll get D2, and then obviously from that, we can get D1 plus D2. So let's work through that. So let's see. What was the first thing I said? Yeah, you want to find T1 first. So how you find T1? It's D1 over V1. Let me just organize it better. T1 is equal to, divide on both sides. D1 over T1. And so it's D1 was 160 kilometers over 98 kilometers per hour. So you can get the amount of hours that this takes. You know what? It may be better to write it as the division of fractions, because I don't know how used you are to how used to this you guys are. So 60 kilometers over 1 times one time would be what was it? Oh my god. My bad. Yeah, you divide by the velocity on both sides. My bad. So 160 kilometers over 1 times 1 over 98 kilometers per hour. I guess we can move the unit like that, so it'd be hours per kilometer. Then you cancel those out, and you are left with hour. You know what? Honestly, at this point it may just be better just to divide the two numbers rather than even worry about the units, because you'll know that it's going to be in time as long as the units are the same. Like you're still working with kilometer, and hour. So 160 divided by 98 is 1.633 hours. And if you multiply, if you want to get it, let's keep it in hours, because we all have the same units for all these things. So it's about 1.6 hours in T1. So we can get T2. It's very simple. T1 plus T2 equals 5 hours. So T2 equals 5 hours minus T1, which we just found. And if you do the algebra, you subtract the 2, you get 3.367 about. 7 hours. Bam. And with that, we can finally get D2. So, yeah. So how would you do that? Same equation we always use. 2 times T2. So V2 was 65 kilometers per hour. And T2 is 3.367 hours. The units cancel, top and bottom. and you get 65 times that number, which would be about 218.88 kilometers. It's a number. All right. And then finally, we can get the total distance traveled, d1 plus d2. And that's, you would just add the two numbers. So total distance is equal to the sum of 218. So this is this distance plus the 160. And if you do that, you would get about 378 kilometers. And they want the answer kilometers, right? Let's see. Yeah, they want it in kilometers. So it's a bit of a long process. I'm not gonna lie. It is kind of a tedious thing, but this really is, I guess, one of the best ways to do this is just to break it down into different subsections of the trip, and kind of look at what you can find and what you want to find in the end. And not gonna lie, it is a very tricky thing. So these type of problems, I would definitely suggest practicing a lot, because it can be complicated to sort of figure out your way to solve it. But besides that, does anybody have any questions? Is anybody confused about any step I did? Or how are we feeling about this overall problem so far? How you guys feeling? You guys really confused, lost?
Not really. It was a good recap of like what I think I learned last semester. So thanks for that. It was a really good recap.
All right, awesome. Thank you. That's good to know. All right. So I'm glad I was able to help you guys get through one of these type of problems. Now I guess we'll move on to part B if everyone feels a bit comfortable with it. So now let's find the average speed. So one thing to know about finding the average speed is it's not just adding up these two speeds and dividing by 2 like you would think. And I'm sure some of you guys may have probably done that and got it wrong. I think I remember doing something like that, and I think when I was preparing for like a SAT subject test when I was still in high school. I remember adding up these two numbers and then dividing by 2, and I was like, why is that not the right answer? But it's kind of defined a bit differently, because and the best way to sort of explain why it's defined differently is that how should I explain this? You travel this speed for, okay, actually, yeah, here's a good way to explain it. You travel 98 kilometers per hour for about 1.6 hours. Whereas you travel 65 kilometers per hour for a much longer period of time, about 3.367. So the fact that you spent more time traveling 65 kilometers per hour actually means that the average speed is going to be more closer to 65, because you spent more time going at that speed rather than the 98 kilometers per hour, because you only spent a measly 1.6 hours traveling at that speed. So I guess that's one way to sort of explain why it's not just that. So let's get down into just the details of how to find it. We actually already broke it down enough to the point where we can easily find the average velocity real quick. All you really have to do is, I believe, isn't it? Yeah. You literally just have to why am I stumbling? You have to divide the total distance by the total time, I believe, right? Is that what you have to do? I think so. Yeah, because it gets weighted. I believe that gets it all. Yeah, okay. Yeah, that's what you would do. You just have to divide the total speed by the total time. Sorry, I'm kind of overcomplicating this a little bit. And okay, I think I figured it out. I just remembered this. I don't need to move that. The reason is because you're dividing the average distance you traveled, which is d1 plus d2 over 2, just regular average, by the average time that it took. And when you do the calculation, you sort of realize that you don't even need these 2's here. They cancel out. I'm not going to go into you can sort of see why if you divide the fraction like you usually would. It would just be 2 over t1 plus t2. So yeah, you could cancel that out. And that's where that comes from. The main point, I'm even just overcomplicating it a bit. The average speed is just d1 plus d2, your total distance traveled divided by your total time, the total time that it took. So the total distance you got was around 378.88 kilometers, and the total time you got is 5 hours. It's already given. So you got your V average already. So divided by 5, you should get about 75 kilometers per hour, about this. And if you did the other way, you would get the incorrect answer. You would, if you just added these two speeds and divided by 2, you would get about 81, which kind of makes sense because the 98 is bigger, and it's not being weighted by anything. This isn't 98 times the time that you were at that speed. In fact, I should write this down just in case it just asks for the average velocity. If it just asks for average velocity, and you have the information that you started off with, would be this over t1 plus t2. What I was trying to explain is you can sort of see why this is smaller than the average you would get if you added these two numbers. Because if you add these two numbers and divide by 2, you get 81.5, which is obviously bigger. The reason is because the speed isn't being weighted by anything. Whereas this speed is being weighted by about 1.6, and this speed, 65, is being weighted by about 3.36. So this speed, 65, carries more weight because you are traveling at this speed for more time. And yeah, the only reason I'm really explaining this, don't worry if this is kind of going a little bit over your head. The only reason I'm explaining this is because I want to explain why this number is smaller than the one you would get if you just took the two speeds and divided them. You added them up and you divided them by 2 afterwards. So yeah, overall, very, simple thing to remember. The average speed is just your total distance divided by your total time. And the reason is because, like I showed before a little bit, it's the average distance you travel divided by the average time. So yeah. Does everybody sort of get how I was doing this? How you guys feeling about this? What are you guys thinking about this right now? You guys comfortable with finding average speed? Or do you want me to go over it a little bit more? What do you guys think? Well,
I pretty much get it.
Awesome. All right, that's good.
Are there any other topics to go over regarding the first comment?
Wait, what do you mean by first comment? Do you mean like
the very first comment, which is starting this.
Oh, my bad. I thought you said comment.
Oh, no, that's okay.
Yeah. Is there any? I mean, I believe they're solving linear equations. As shown by, I guess, sort of more at the top. There's some things where you have to solve for x, but that's practically what we've kind of been doing the whole time when we're, solving for like the velocities and stuff and distances and whatever. And I think there's also significant figures. I saw. I think there's units, like how to convert from units. Do you guys want me to go over that, or are you guys feeling? I guess. If there's anything you want me to go over, Julia? I don't know. How you guys feeling?